All right, let's go. Class?
Yes.
All right. Okay, so for those people not playing on their phones that actually still want to graduate in a week, how many days we have left? 9 days from right now. Okay? So, if you're on your phone, I might lose my stuff because I'm trying to get you to pass. The last 10 questions of your final exam has to do with Unit 8. I want you to do success. I want you to be successful. I want you to do very good on this final exam. So that's why I need you guys paying attention for this. And I don't want to see your phone out again.
Attention all staff and students. We have a police situation on Central Avenue at this.
All right, so there we go. Back to this again. So for this, again, I need to get to the last bit of this so you can be successful on the final exam. Right here, we're going to do complex numbers. Complex have to do with imaginary. Imaginary numbers like I is the square root of -1. We've had some of this before, hopefully. You've had some in Algebra 3, right? Algebra 4, something like that. Algebra 1, 2, all that. So this says that I is the square root of -1, and when I square a square root, it cancels out my radical, so I'm left with just right here. Now, we need to set up our calculators to be correct now. So let's go ahead and write down the steps to change my calculator. So I'm pulling up mine here. We're going to start by going home. Right? Home. So on your calculator, you're home. We go 5. We go document settings 2. And we are going to, right here where it says real complex, I'm going to change this to rectangular. We will use polar later on. Right now we're doing rectangular. Are we okay?
No.
Did you write it down? Did you write it down?
Here.
2, real and complex, rectangular.
Change it to rectangular. There we go. And then I'm going to bring up my scratch pad. All right, here we go. So I want you guys to try this real quick. So square root, -25, hit enter. And normally that negative inside the radical would give me a non-real answer. It would say non-real. So this one being in rectangular is going to give me non-real, so it's 5i is my answer. I know it says 5 times I, but it's 5i. Does that make sense? Okay, good. So let's go ahead and take a look at, this is the way to write a complex number, which is a plus bi. A is my real, bi is my complex, meaning I have a direction here. This is my real direction. This is my imaginary direction. So this is actually going to be just like your x and y coordinates. We have, so you're going to go first in the real direction, and then you're going to left and right to your imaginary direction. We're going to get more into that later though. But we just have to write our numbers in this fashion. Blah, 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 blah. Okay, see this right here? This is in your notes. Let's say, for instance, I have the number 13. Let's say negative 13. Negative 13. Where would negative 13 fall in this Venn diagram? Integers, right? So negative 13 would be right here. What else would it be? If it's integers, what else is it inside of? It's in rational numbers. What is it also inside of?
Real number.
And what is all that inside of?
Complex number.
There you go. Pretty basic, right?
Yes, sir.
So you find it on here where does it go, and then it goes from there. This is actually questions 7 through, I don't know, like 15 or something on the homework. That it looks like this, okay? So it starts here, and so it's just asking which ones it fits in the category. So list all that it fits. Okay, so you're going to end up using this. Blah, blah. All right. So you can do this 2 ways. You can do it in the calculator, but I highly recommend doing this by hand because you've got to know your numbers. You really do. So what I'm going to do is this right here. So I'm going to break down the square root of negative 16 into 2 things. So it's going to be, there we go. So I break it down like this. Negative 1 times 16. What is the square root of negative 1? I. It's I, right? So I'm going to circle this piece right here. So that becomes I. So that comes outside of my radical. So the I goes in front of my radical now. What about 16? What's the square root of 16? 4. So that is also going to break down. That's also a perfect square, isn't it? So this answer is going to come out to be 4, and square root of negative 1 is I. Just like that. Does that make sense or nonsense? Más o menos? All right, let's do another one. So let's do, what did B say? Negative 70? All right, so we're going to break this down. What's the first thing I'm going to factor out? The negative 1, right? Because the negative 1 is my I. So I'm going to circle that. Times 70. Now, is 70 prime? It is composite. So composite means it's made up of multiple things being multiplied together. So what are the prime numbers? So I'm going to break this down into the prime numbers that would go with this. So to get 70, I would multiply I think I heard some of this. 710 sounds pretty good.
Yeah, that's what I'm thinking.
Okay. I heard a couple different versions and it'll still work out. And so is 7 prime? 7 is prime. I can't break that down further. Is it a perfect square? It's not a perfect square, so I'm going to leave that alone. Next one, 10. 2 and 5. 2 times 5. Now, let's look. Prime. Right?
Right.
I can't break it down any further. And is there any more 7s here? If there was 2 7s, I would put those together to make 49. Because the square root of 49 would be 7, right? So, I don't have any more perfects, do I? I don't have any perfects. So what's going to come out of my radical? Just the I. Only the I is going to come out. So I get I, square root. And what do I do with all this other stuff that's there? Multiply it. Let's put it back together. So 7 times 2 times 5 is going to give me 70. Because there isn't any perfect squares inside there, it just goes back to being 70. I factored it down to primes to looking for perfect squares, but I didn't find any. Does that make sense? Kinda? Maybe?
Can you do it like with different numbers other than 7 and 10?
Okay, what do you, okay, let's try this. Break it down. So 70, what does that break down to? What do you say? What other numbers?
Is 2 and 35 one?
2 and 35.
Yeah.
Alright. Is 2's prime, isn't it? Can't break down that further. Can I break down 35? What do you get? I get what? So do I still have 7, 2, and 5? And just in different combination though, right? So because they're prime, no matter the combination right here, they're still prime. It's just I'm changing the order. Does that make sense? So yeah, different combinations just going to give me same thing. Yes.
So you only have to do it once.
Yeah, you only have to do it once. She asked for a different breaking it down, but we still end up with only these 3 numbers. All right, so let's go back. What's the next one is? There you go. All right, factoring it, right? What's the first thing I'm going to factor? Very good, -1. So it's -1 times. Very good. So I'm going to circle that because that one's already a perfect. It's an I. It's going to go outside. So what about the 48? Say it one more time. 6 times. Okay. 6 times 18? 8. Oh. I'm sorry. It's like you're wearing a muzzle. I could barely hear you.
But you wrote it down.
But I put 18.
Yeah, you wrote down 18.
I said I could barely hear you.
Yeah, but you still wrote it down, knowing it was wrong.
I didn't write the right thing.
Yeah. Exactly.
Yeah. All right. Are both of these prime? Are either of them prime? No. Can I break down the 6?
Yes.
What do I break down to?
2 and 3.
What about the 2 times 4, right? All right. Is 4 a perfect square? I'm going to circle the 4 because that one is a perfect square. Right? I do have another one, don't I? Because I have 2 2s, don't I? So since I have 2 2s, that's also going to be another 4, isn't it?
Sure is, because you got to multiply.
So watch this. Bam, bam. So I'm going to make another 4 over here. Because I have 2 of them, because the square root of 4 is 2. Yep, and that's how I did this. And so is 3 left over?
Yes.
Is 3 prime?
Yes.
Yes, it is. 3 is prime. I can't break that down any further. So now, all that comes factored out. What is square root of 4? 2 times another square root of 4, which is
2
times I, right? I, and then square root of,
3.
which is left over.
Wait, so why didn't you put the 2's inside the square root?
Say what again?
Why didn't you put the 2's inside of the square root?
Okay, so what is, see this right here?
Right.
See this? This actually says square root of 4. And this is also square root of 4. What is square root of 4?
2.
This one is that 2. This one is that 2. By factoring it out, it actually rewrites it. So here, let me list this. Maybe this might actually help. It's going to be -1 times, what's that going to be? Let's say 4 times 4 times 3. That's one way of writing it, which would give me square root of -1 times square root of 4 times square root of 4 times square root of 3. Maybe this might help explain it a little bit better. Because all these things being multiplied together, because 4 times 4 is 16, 16 times 3 is 48. 48 times -1 is -48. So they all get multiplied together anyway here. Does that make sense now?
Why can't you just put the 4 times I times
I'm going to. I just haven't made it that far yet.
Oh.
Oh, I'll show it.
Okay? So 2 times 2 is 4, so it's going to give me 4i radical 3.
Oh, okay.
Does that make sense now that I finish?
Yeah.
We good? Question? Alright, so let's see. Okay, now we're going to do for solutions to equations. Now, previously we did equations where we set everything equal to 0. You can't really do it like this now because it's not going to be equal to 0. These are non-real solutions, so you're going to get i's. So you can't really graph a non-real solution. So what I'm going to do is, we're going to try and solve by hand. So to undo a square, what do I have to do to undo a square? Square root. But when I square root something, what can I not forget? Plus or minus square root of -9. Plus or minus square root of -9. But now, what is that negative going to give me? That's your I. What about the square root of 9? 3. So your answer is going to be x equals plus or minus 3i. Does that make sense? Now, as a solution, yes.
If it's negative right there, then why did, if it's the -9, why do we need the plus?
See on this inside?
Yeah.
This negative is this right here. That becomes the I. That's the negative. I factor that out. But every time I take the square root like this, there's a possibility of it becoming positive or negative. Does that make sense?
Yeah.
So that's where I get that from. So it's a possibility of one being either or. So as a solution set, it's going to be in braces. It's going to be -3i, comma, +3i. Now, on part B, I'm going to do it by hand. I want to try and isolate my x squared. So what am I going to do first? Subtract the 24, right? So I get x squared is equal to -24. So the next step to undo the square? Very good. So x equals plus or minus the square root of -24. We have to go factor that one. There is a perfect square in there. 6 and 4, right? So this would break down. It would be 6 and 4. So it's -1 times 24. And then 6 times 4. 4 is a perfect square. Does 6 break down into anything else that I need? 2 and 3. Those are just prime, aren't they?
Yeah.
2 is prime and 3 is prime. So I can't break it down further. So I don't have any more perfect squares, do I? So what is my answer here going to be? X equals plus or minus 2i, 2 times 3, which is? Because if you have more than one left over, inside your radical, you just put them back together. Just multiply them back together. So my solution set, braces, it's -2i rad 6 and +2i rad 6. I have one more type of problem before I let you guys start working on this. So we're going to do the quadratic formula here. Now, quadratic formula has to be in descending order. And it also has to be equal to 0. Is this problem right here equal to 0?
No.
What do I have to do with that 6x? Very good. I'm going to subtract it for both sides. So I'm going to have 9x squared minus 6x plus 5 equals 0. And now it is in order. So this is A, B, and C. So I have my A, my B, and my C. And we're going to plug those in and put it together here. as my problems on my formula. So when I'm plugging in, I really want to make sure I plug in using parentheses, especially with these negatives. Because when I have two negatives next to each other, it becomes what? Positive, right? Two negatives become that positive. So I'm plugging those in. I get negative parentheses, negative 6 plus or minus square root of parentheses, negative 6 close squared minus 4 times 9 times 5 all over 2 times 9. Now when you're doing this, I'm going to show you what you put in the calculator to simplify your life. Don't put all of it because it's going to be a pain. Just that. Only put what's inside there in the calculator. And then we are going to simplify.
Not even the square root we don't put in?
Don't put the square root. Don't put the square root because sometimes it's not going to be a factorable. You only want to put it on the inside. Because remember, if it isn't a perfect square, your calculator is going to give you a decimal. I don't want you to get there. So, the step is, yes, on this one, it does come out to be a simple 12i, right? Or negative 144. Yes? So, step by step. Negative is going to make that a positive 6 plus or minus, let me see, square root of negative 144 all over 18. Now, the negative 144 is going to simplify really easily because the square root of 144 gives me what? 12, very good. And that negative is going to make it, so it's 12i there, right? So this is going to give me 6 plus or minus 12i over 18. And it has to be in the format of a plus bi. So you have your real plus your imaginary. So if you notice, the 12i is an imaginary part, right? And the 6 is my real part, right? Yes? Okay, so now we're going to separate the fractions here. Separate the fractions. So it's going to be 6 over 18 plus or minus 12i over 18. So now I have my real a's and my imaginary b's. Can I reduce these fractions? Say yes. Okay, good. So what is 6 over 18 reduced to? 1/3. Plus or minus 12 over 18. 2i over 3, right? And my solution set is positive 1/3 minus 2i over 3, comma, 1/3 minus 2i over 3. Oh wait, plus, sorry, got 2 minuses there. Does that make more sense or no? Nonsense. We did quadratic formula. I did it with a lot of y'all people in this class last year. If you actually did it, most people just cheated while they're online anyway. But all right, so I'm going to pause here. I'm going to give you time to practice this, and then I'm going to do the next example. All right, let's go. All right, let me see. All right, class.
Yes.
Try again. Class.
Yes.
Yes.
Supposed to say yes.
Oh, try
Okay,
Supposed
that's
to
it.
say yes,
Hold
yes.
on. Let's try this. Class.
Yes.
Class.
Yes.
All right, that's better. Okay. Anyway, so we're going to do example 4, and then I'm going to leave you alone. So right here, when we're looking at this, we're multiplying two things together. But there's something really important. So when I multiply this, I'm going to rearrange it as I multiply. And if you're playing with your phone, I'm going to get mad. So this is going to turn into the square root of -1 times -1 times 7 times 7. So I'm putting this all under one radical. So it's a little bit easier to see. Now, this is going to be, isn't this -1 squared? Yeah?
Yes.
So this first part right here is going to be I, right? Because it's I squared. Because I have I times I, right?
Right.
But then this other part is going to be the square root of, what's 7 times 7?
49.
There we go. Now, what is I squared? I? -1. Very good. It is -1. Because remember, I is square root of -1, right? And I squared, what happens when I square a square root? Canceled my root, right? Cancel root, so you're left with -1. So, right here, this is going to change. And so this is going to give me, so square root of 49 is 7, right? So it's 7 times I squared is -1, so I get -7 as my answer. Yes? Good. This next thing, let's take out the i's first. So I know that's going to be an I times I, right? Is that I squared?
Yeah.
Good. And on the inside, it's going to be square root of, what's 6 times 10? 60, right? Now, using your noodle here, I can factor the 60. What's a perfect square that's in there? 4 times 15.
Oh, surely.
It's 4 times 15.
Okay.
Yep, like a quarter till. Quarter to 10.
And 15 doesn't factor any further. It is prime, or it's not prime, but it only turns into 3 and 5, right? So there's no more perfects. So my answer is going to be, what was the I squared? So it's negative, what's the square root of 4? And what's left over on the inside? There we go. And on letra C, let's take out those i's. If I take out an I, rad 20 over I rad 2. What happens when I have an I on top and bottom? Cancel. Whenever I have something, the same thing on top and bottom, I cancel it, right? So what I could do here, since I have radical over radical here, I can combine it under one big radical. 20 over 2. What is 20 divided by 2? So I get radical 10 as an answer. And this next one, take out that I, you get I, and then big radical, 48 over 24. But what is 48 over 24? 2, isn't it?
Oh, surely.
So I just get I radical 2. Because there's nothing left on the inside that will factor out. Alright, don't forget, like, share, and subscribe, hit that notification button, and I don't know, I have to come up with a new promo code for this month.